Okay, so what do you have here? Simple. Now over here, right? This one is not notes slash straightforward, but it's like a summarized version. So you cannot just read these. You need to make sure, what we're dealing with lah. This thing, right? You go through. Okay, it's like a reminder for you. Now, whatever we're doing today, right? Very simple because I think every no matter what school you go to, lah, right? Chapter 2 is the thing that definitely will come out for a midterm. Because some school they tell me that my exam until chapter 2 only, chapter 3 not coming out. Most of you lah, definitely 2 come on. Chapter 3 also got the one of course depends on school. That's why I chose chapter 2 to do it. Because for chapter 2, right, it's something that I think most of you benefit from. Now, of course, we're not going to do the whole chapter 2 because it's actually kind of long. So what happened is, over here, I picked a few topics that I think very important. A few things. Number one, the early topic that you might remember, might not. Say kind of forgotten already. Now I think your school done chapter 2 already, right? Yeah, your school teacher supposed to finish, kind of do or maybe you're doing chapter 2 now, but ending of it, right? So this is the beginning part of it, right? You got ticker tape, and then linear motions thing, right? Short thing, a summarized version to remind you lah. Then after that, you got the momentum part, or the collision thing. Then you can see, give you all these applications, you go through. Then after that, we have the impulsive force, definition, formula as well. Now, regarding formulas, that one, right, you ask your teacher whether got formula sheets or not. Because every time you ask me, hey, the formula got give or not, formula got give or not. That one, I can't tell one. Every school different. Some school got give, some school never give. Depends on school. Yep. If they got give, then give. If not, then you have to remember. But over here, I provide it for you. Formula. Okay? Now, so I mentioned this first. Number one, formula sheets. You look at you see your teacher. She got give or not. Depends. Now, second thing, the answer for this notes, right? We will post eventually on. As in again, whatever you find the PDF file, there will be answer there. Okay? Now, if you are my own students, then I will also post in the Google Classroom as well. Okay, but if you're not, you're newcomers whatsoever, check the website. Okay, DC website got it on. Okay, all right. Now, so main thing I want to do today, right? The linear motions, the momentum, and the impulsive force. 3 topics. Okay, formulas wise, I give to you. All right, this one, and then this one, and then this one. After that, right? One more thing. If you look at your notes, right? Okay, these notes are you probably notice it's kind of thick. The reason very simple. If you go to page number 21, you will see over here I put like this midterm exam revision questions. Now this one, right, I memang do more for you. This one here, it's a revision set for you to prepare. We're not doing this anyway, but the questions here, it's like extra question I made for you. Okay, because a lot of times, especially midterm, it's the first exam for Form 4. You have no idea what to do. You say, I don't know what to study. I don't even know how to even begin with. Over here, you have a simple revision kit. Go and do the questions. All these things I've prepared for you. Inside got chapter 1, chapter 2 also got. Okay, and also hopefully we got time we can do the essay part as well. Okay, now so let's start Over here, first thing first, linear motions. You can see this one. What we have, it's the linear motion equations. Do you remember this? I think you kind of gone through this before. Does it rings a bell? I think you do, right? Now, over here, we call this as the Suvat formulas. Why do we call it Suvat formulas? Because over here, you notice, right? Every formula is made of these 5 letters. SUVAT. Okay? Now, by right now, you're supposed to have basic over this thing. Displacement, velocity, initial, final. A means acceleration, so it can be deceleration as well. If it's a negative value, means decelerate. And then finally, T for time. Okay? And the unit, very important. I can see I put all the unit here for you, just in case. Okay? Now, let's go to the question number 1. It's regarding this linear motion one. Now, formula I copy for you. Never mind. Now, is this not exam? You can always refer. See, over here, what we have is question number 1. Diagram 2.1 shows a boy playing skateboard. Right, formula I put here first. Yeah. Okay, so first thing, question A, based on diagram 2.7, calculate, right, acceleration of the boy from A to B, calculate acceleration of the boy B to C, and then after that, calculate displacement of the boy from B to C. Now, every time you see question asking you calculate like accelerations, velocity, time, displacement, then you know this is about linear motions one. Why? Now over here, your SUVAT formulas got four things, right? Displacement means distance, and then you have velocity, initial, final, same. Initial means the beginning, final means ending. A means acceleration, obviously, and then after that you got time. So you see them asking you questions like that, then you know it's about this linear motion thing. Okay, so every time, right, what we do, we list down the criteria first, because over here we have a problem. We got four formulas, and I get this a lot. Every time people tell me, hey, I'm not sure which one to use though. How am I supposed to do this? Well, simple, straightforward. You see, over here, every formulas, okay, now as much as I said, they are made of they are made of 5 letters, SUVAT, SUVAT, right? But do we really use up all 5 formulas? If you look at them, do you realize one thing? We don't really use all 5, right? 5 alphabets, no. Every formula's only 4 letters right now. Now, for example, if you look at the first one, SUVAT. Now, if you read out, you notice one, SUVAT. What is missing out? What is the thing that is not inside? Yep, inside don't have A, right? That's how you do. So this is why people probably will ask hey, why got 2 formulas to calculate S1? Isn't it the same thing? Well, that's the main reason. This one, first one, there's no A inside. So you choose formula according to whatever is not provided. So why should you list them down? It's because you have to choose. Now the second one, what is missing out? The second formula is what is not inside. Again, you read out SUVAT, SUVAT. Do you realize inside got no V? Third one, S missing out. Fourth one, the final one, what's missing out? Yep. So what do? We list down the criteria first. Every time they ask you to do any calculations, what do is you list down SUVAT. Now how do we do it this way? Every time, right? First thing first, what they ask you to calculate. What was the question asking for? Ask you to calculate the accelerations of the boy, right? They're asking for the acceleration of the boy, right? Acceleration means what? Which alphabet letters are we looking for? Yep, acceleration means A. So that's what we're looking for, A. Now then, after that, we list down one by one. Number 1, displacement. Now, they want A to B. A to B means over here. This part, A to B. Displacement. Did they tell you the distance travel for this part? From A, you go to B. Any distance, any displacement travel? Well, if the question never give it to you, then you put a cross there. Okay? X means the question never give. Now, every time, your SUVAT must have only one question mark. That's your questions. And then 1x means the question not provided. They didn't give it to you. Okay? Then after that, U means initial velocity. What's the starting speed? Now, again, I want A to B. So what is the starting speed? Starting here, A, right? And then ending here, B, right? 0 means starting. And then after that, ending means 2. Are you following? Okay, a simple question. I go faster. Now, finally, time taken, how long? A to B. You can see 0 seconds become 2 seconds. How long does it take? 0 become 2 seconds. That means 2 seconds, right? There you go. Now, once you're done with this already, right? What do? Choose your formula according to not the question mark, but this one. Yes, you know why not? You know why you must list down this? Simple, because you need to know what is the question what is the information they never give. They got no S. So what do? You have to make sure, right? You choose formula with no S inside, because you got no value, So you want to make sure you avoid having S inside because you don't know the number. So of course, among 3, right, which one we supposed to choose? We don't have displacement travel. That's how you choose it. If they don't have final velocity, then choose this one. If they don't have acceleration, choose this one. If they don't have time taken, choose this one. Now, no. This question, you cannot tell me number 1 because why? You are calculating A. So A must be inside one. If you say, oh, hey, shouldn't we do the first formula, this one, right? You think about it, they want you to find out the value for A, and then inside a formula don't even have A. What are you looking for? You get it, right? So this one here, what we're doing, we're supposed to do V equals V plus, that's right, V equals U plus AT. Substitute accordingly, you get answer. V means final velocity 2, U is 0, A is what you're looking for, and then time taken 2. And finally, what do we get for mathematics? Answer? How much? 0 means nothing and then 2A equals 2, obviously A equals to 1. Answer must have unit. Your final answer must put unit. What's the unit for accelerations? ms negative 2. There you go. Got it? Nah, that's it. Quite easy, right? Can I use acceleration punya formula? It's the same thing lah. Yeah, up to you lah. Both also correct lah. It's the same formula. They are just, you're just shifting them around. You'll notice one actually. A lot of people ask like, hey, can I do the formula for acceleration for this? Do you notice the fact that actually this one and this one is the same thing? Yeah, you see, this one divide time, right? You bring over and see. You get AT equals to V minus U, right? You bring this over again, you get V equals to U plus AT, right? Isn't them the same thing? Yes, same actually, right? Okay, next one. Calculate accelerations of the boy from B to C. Same thing also. We write down so what first? What are we looking for? Also, calculate accelerations. Right, this one, question mark. Now, I want the acceleration from B to C. So now it's from B to C, right? Here to here. Again, is there any displacement provided to you? Did they tell you how many distance travel here? Not quite right. Okay, never mind. So we leave it there. Don't have. U, initial velocity. What's the initial velocity of the boy? No, this one cannot be 0 anymore. Because they want B to C. So if you look at B to C, what is it? Starting is here, right? Just now, right? Like this. They want A to B. So initial, final. Now what happened? This one here is going to be starting and then ending. Starting is 2. Ending is 3.5. So initial velocity is 2. Final velocity 3.5. Time taken? What's the time taken? What's the time taken? No. 2 seconds to 5 seconds. You can't tell me 5. Because 5, it's from here to here, everything. But I only wanted B to C. Yup. So you're supposed to put 3. How do you get the 3? How do you get the 3? 2 seconds to 5 seconds. Minus them. Okay? And then, yes, I think you shouldn't have any issue, right? This one here, straightforward. I got no displacement travel. So straightforward lah. Same formula anyway. Okay? V equals U plus AT. You following, right? This one easy question. I go faster lah. Final velocity 3.5. Initial velocity is 2. A equals to what you're looking for. And then time taken 3. So, I bring the 2 over, it's minus. So 3.5 minus 2, 1.5. 3A. A equals to how much? Bring the 3 over, 1.5 divided by 3 again. What is the final answer? Here. What is the final answer? 1.5 divided by 3, I think we get 0.5. Is it? Okay. Unit. ms negative 2. Velocity minus 1. Okay. But then accelerations, right? Minus 2. Okay. Only accelerations. That's why I say recognize unit. Now, unit very important one. Final answer must have unit. No unit. Minus 1 mark. Get it? Okay, good. Next one. You need to calculate the displacement of the boy from B to C. How do we get this? Same thing, right? Step 1, SUVAT. So what list down first, right? What are we looking for? What are we trying to calculate? Displacement of the boy means, displacement means S. U is, now again, the one B to C means actually, same thing lah. So initial 2, final 3.5, A, cross out, time taken 3. Okay, guys, pay attention, look here. This one you should ask like, hey, why the A cross out? Okay, I thought A is 0.5. Now, normally when we're doing calculations, especially this kind of continuous questions, try not to use your own answers. Now, is it a must? Like, I'm not saying you must not use, but it'll be safer if you don't use own answers, because why? There'll be a risk there. If this is wrong, you bring a wrong answer down, it's wrong, right? Now, I'm not saying cannot lah. To be honest, can I use 0.5 to continue calculating? Of course can, up to you. But again, what did I say about X? What did I say about X? X means what? The question never give, I put X, right? How do you think about it? The question memang never give, right or not? They didn't give, right? Those my answer, right or not? So always, right, if you could lah, most of the time, right, you got more than enough information. Now, there are cases you got no choice, where the questions, they got not enough info. You have to use your own answers and then from there. That's fine, totally fine. But then, try not to use your own answers if you could. Okay, but if you got not enough information, by all means, just use only. But now, simple, because you got the question never give me A, so I put across there. Okay, so now, which one do we use? Which formulas with no acceleration inside? You're looking for S. S must be inside. Which one got no A inside? U over here, first one. Okay, substitute inside, we got answers. S equals to U plus V over 2 and then multiply by time. S is 2, V is 3.5, divide by 2, and then multiply by time. I need you to help me to calculate. Yes, press calculator. What's the final answer? What do we get? 8.25. Unit for displacement. Displacement is like distance, but then with directions. So what unit do we do? Yes, meter. No, actually, you don't need to put unit here. No need one. During working, don't bother. Of course, very long. You don't have to lah, because your working get very messy and lengthy. So only final answer must put unit. Unit. Normally, calculation questions like that, 2 marks. The easy calculation is always 2 marks. Okay? No lah, the marks, don't worry, they will give one. They will put a bracket there and then say like 3 marks, 2 marks. They will give it to you. Okay? But doesn't matter the marks lah. Question do only lah. The more you do, the more marks you get anyway. Alright? There we go. Okay? Alright, to this point, straightforward, easy questions. I start off easily first, then we go more and more and more. And also, when we're doing questions, right, you will notice one, we will have more, we will have like a different variety of topics. Okay? Because exam is like that. They're not going to ask you like one by one, you know. They're not going to say like, oh, now I test you 2.1, now I test you 2.2. They don't. Everything combined, they ask together. So you will get questions a bit of 2.1, a bit of 2.3, a bit of 2.6. They all put together. Okay? So I doing this way is because, number one, I want you to be familiar how the question asks. And then I want you to be comfortable with jumping subtopics. Not a must, I must 2.1 all the way. Okay? Are we done for this? Everybody, any questions so far to this point? All good? Can I get an OK sign? You send me an emoji like this. Then at least I know you are following, you got no problems, then I can move on. Because okay, let me clarify this. You got questions, you ask straight away. If you have any questions, ask. If you don't want to ask, you say I shy you can wait until end of the class. I will stay on for a while, then you can ask again. Alright? But when I move on, you move on together. When I say move on, you move on together with me. Because here's the thing. If you stuck there thinking, hey, why like this, why like that, then when I move on, you are missing out even more. So if you got questions, you can ask straight away. If not, you keep it first. Then later you ask. But when I move on, you move on together with me. I want everybody move on together. We leave no person behind. Okay? Alright, next. Skateboard. So now what we have, diagram 11.3 shows a girl wearing helmet and safety pads. And to be honest, copying is okay, but you must know what are you copying. Right? To be honest, all these things got answer one. I will give you the full answers. Like every question I give answers one. Right? So you doesn't part to copy is fine. You can't make it to copy, it's totally fine. You understand or not? You can always screenshots. But most importantly, I need you to listen and understand. Memorizing don't work one. Understand is most important thing. You got a question, you can ask, you can screenshot the answers, up to you. But answer my questions. Okay? Now over here, the girl wearing helmet and safety pad during skateboard. Why the girl needs to wear helmet and safety pad? Now, in exam, physics is not just calculations, one got theory. And usually these kind of theory questions they ask you to explain are usually those explain questions, right? This one is 4 marks one. So here's the thing. Here's the thing. When there's 4 marks, of course you expect, right? You need to write more. And then I noticed one thing. You all always give me answers like, oh, why the girl need to wear helmet? So that she won't injured. No. Must it 4 sentence? No. You need to have 4 points. Like, writing essay. You got 1 essay and then Hurayan. Like EC Hurayan, EC Hurayan. You get what I mean, right? So 4 marks. You need to make sure your answer worth the marks one. And I tell you what, this one, how do we do it? 4 marks, right? I always like to do this approach. We go from the formula first. Now, first of all, what do you think this one refer to? Helmet, safety pad. Yes, protect her. Don't injure. Why the girl get injured? Without the helmet and safety pad, how come injured? Simple. When you fall down, okay, play skateboard, you're gonna fall, right? When you fall on the ground, what is the topic involved here? How come we injured? Because the moment when we fall, what is the force acting on our body? Now listen to my questions. When we fall, okay, we land on something, let's say on the ground, hard surfaces. What is the force acting on our body? I'm asking for the name of the force. So what's the force acting on body that going to injure you? Now, you know why people confuse or not? Number one, you tell me gravity. You tell me gravitational force. What is I'm asking you what's the force acting on you. I'm not asking you why are you falling. Now, the reason you fall, you tell me gravitational force, correct. But when you fall, why do you get injured? Because you got something called impulsive force. Okay, impulsive force. Every time when we collide, you hit onto wall, hit onto the ground, whatever. When you collide, the force acting on you, there will be impulsive force. Okay, here's the questions. Do you remember the formula for impulsive force? You don't have to. Just check in front. Yes, that's why I give you the formula, man. Because I expect, of course, you're not going to remember all this thing. Impulsive force formula, here. Impulsive force formula, here. Okay? mv minus mu over t. Okay, impulsive force formula, F equals to, impulsive force formula, F equals to mv minus mu divided by time. Okay? Now, so what is our target here? What's our goal now? Simple. If you don't want to get injured, okay? If you don't want to get injured, right? Then here's the thing. Do you want more impulsive force or less impulsive force? If you do not want to get injured, of course lesser. Where got more? Hello? More than the bone will break what? Of course lesser, right? Okay, then how do we make it lesser? Okay, we do the maths way. You look at this thing. This is a fraction, yes? You know it's a fraction, right? Okay, so if I want lesser value, what happened to the number behind, at the bottom? A fractions. How do you make the number lesser? Do you put a bigger number here or a smaller number here? Okay, I teach you a simple trick. Every time you don't know, very simple one. It's a fraction, yes? Okay, now on top we don't care, I put 1 here. Okay, let's say I put 5 here. 1 divided by 5 equals to how much? Mathematics, 0.2. Good. Now, if I increase it, let's make it 10. 1 divided by 10, how much? 1 divided by 10 equals to 0.1. It goes from 0.2 becomes 0.1. What happened? Is it increasing or decreasing? Yep. So that's how you know the relationship. You understand? It works for every single formula. Every chapter also can do that. Whenever you don't know the relationship, right? You know what you do or not? Put number inside and see how they behave. Substitute number inside and then you see how they behave. Okay, one more thing. It's a fraction, yes? So my questions now, beside this, what about the value on top? Again, if I want this thing to decrease, right? This one I keep it. What about here? Should I increase or decrease the value on top? No, you don't care what is minus whatever thing. I'm just imagine it's a number. Should you have more or less number if you want lesser impulsive force? On top supposed to decrease. Now all fraction like this one, all the fractions are the value at the bottom here and your total number, the balik. This one increase, this one will decrease. Okay, the number on top and your force here together means this one decrease together. Okay, example. Now I'm asking you, what's the relationship between this number and this number, right? Let's see lah. For example, I make it 1 here. If this is 5 divided by 1 equals to how much? 5, agree? Okay, let's make it 10. 10 divided by 1, what do we get? 10. So what's the relationship? This one increased, this one also increased together. There we go. Can? So now, if I want F to decrease, what happened? The value on top, you don't care MV minus MU, whatever thing. Just see the whole thing. The whole number here supposed to increase or decrease? Whole thing. Yes, decrease. What about the bottom value? This one? Increase or decrease? The number supposed to increase. Are we good about it so far? But think about it lah. What do you think you should do? I mean, which one is easier to achieve? Reducing the value on top or increasing the value at the bottom? Both give you lesser force. Exactly. And to be honest, actually every time when we try to reduce impulsive force, right? When we try to reduce impulsive force, I actually got one answer only. This. Because if you think about it, you know this one, you can't really change any on it. You can't change anything on top one. can you change the mass? Because theoretically, yes, if you want a lesser force, this one drop, okay, reduce the mass. But can you reduce the mass? No, I'm not asking. Some people say, oh, then make sure the person it's lighter. No, the mass here refer to what? Before you collide and after you collide. Can you suddenly change the mass? How? Cannot, right? Is it? This one cannot change, right? Okay, next, final velocity. You know how much is it? Most of the time, when you collide onto something, when you land on the ground, the final usually how much? They are usually 0 because you stop, right? Then what about you? Some say, oh, then what about you? Initial speed. Can I change the speed? Starting? Or go slower, right? Now, if you know you're gonna fall, of course you go slower. It's more safer, right? But the problem is, if you know that you're gonna fall, you know that you're gonna have car accidents, you're not gonna even collide, right? So this one also cannot change one. So ultimately, there's only one thing we do. We try to lengthen the time. Now, by the way, what do you call this? If you call this time, it's not accurate. You know what is the T here stands for? What time is this? This one, right, actually means time of impact. Okay, some people say collision time, some people say impact time. Same. Now, a lot of people don't realize this actually. When we say time of impact means what? The moment you collide, the moment you touch until you stop. And usually, how do we change the time? How do you control the time impact? You manipulate one thing, the material. No, whatever it is, whether is it like a say skateboard, whether is it like a car accident, whatsoever. Normally, how do we control the time? We control the hardness of it. How do you control the time of impact? Depends on the material. Okay, material hard and soft will usually control time. Your material hard and soft, they will usually control the time of impact. Now, what does it mean by that? For example, okay, wait, let me get something. Okay, now let's say for this, let's say you got this simple material here. Now, what do you think about it? This material, is it going to be hard or soft? What do you think? Does it look hard or soft to you? This thing, very soft, right? So what happens if you land on something soft? Do you feel pain or not pain? Not quite, right? Okay, why is that so? You see, how come when we say, why do we say when the material is soft, the time no longer? Because you see, let's say here now, this thing, when you collide, you notice what happened or not? You notice it kind of went inside one. You notice now? Now you see, the moment I collide, right, I don't stop straight away. So the time taken, right, from here we start 0 second onwards, 0, 1, 2, 3. Notice or not? When I punch inside, they got more time, only I stop one. Okay, but let's say on the wall, notice what happened or not? The moment I collide, you realize my hand stopped straight away. Can tell difference or not? This one versus this. Hard surfaces, right? Your hand stop 0.5 seconds within 0.2 seconds, right? But this one here, 1 second, 2 seconds, 3 seconds, only I stop. You see the difference or not? That's the thing. So most of the time, right, when we want to reduce the time of contact, time of impact, we usually use different material. Softer material gives you more time, and then harder material gives you lesser time. Understand? Can. Now, I'm not sure whether you can hear or not. We can try this also. Can you hear myself? Hello? Got sound, right? Okay, now I put it here. And if I try to punch the wall, you hear? Can you hear the sound? Does it sound hard or soft? Does the sound sounds like the force big or small? Having a huge force, right? Like that. It sounds louder. Okay, good. Now we change this. If I do this, right? Do you realize the sound like a bit muffled? Does it sound like big force or small force? The sound like that. There you go. Understand? There we go. Yeah? Now come back to this. So, how do you make sure the girl don't get injured? Now, actually, do you realize or not? The safety pad, the helmet, they all got one thing in common. What's the common thing between the safety pad and helmet? What material? Hard or soft material? Now, the safety pad, soft one, right or not? And then what about helmet? Okay, helmet need to see, helmet got 2 layers, right or not? You got outside layer, you got inside layer, right? Okay, the outside of the helmet supposed to be hard or soft? Outside. Outside, of course, hard lah. Where got soft? Outside soft, then we have a problem lah. Huh? Okay, if you have you seen this kind of helmet before? Bicycle helmet, or even let's say motorcycle helmet. Okay, I give you a better word, guys. Look here. Outside, right? Instead of saying hard, you know what's the better word to use? I will suggest you guys use this. Strong is even better. The word you're looking for is actually called strong, because you don't want them to break apart. So when you learn katok, it won't break. But then the inside of it, have you seen before? Inside. Normally inside you will see like made of sponged, or maybe like it looks a bit white color-ish, right? Look a bit like styrofoam like that one. That's a foam, hard or soft. Cushions, hard or soft. There we go. So outside, this one you make a remark outside of it, outer layer, outside, outer layer. Okay, we normally choose stronger, so that when she lands, the whole thing soft, we have a problem now, because you want to make sure, right, when she lands, this thing don't break. So outside should be strong, so that they don't break, they stay there. And then inside should be soft. So when your head, the part where your head contact, you want it to be soft. So inner part should be soft. But then outside is supposed to be stronger. So you do not want them to break apart. Too weak, not good. Okay. Now, same thing also, right? Do you realize the safety pad also? The safety pad inside got sponge and everything. Same thing anyway. So usually you want to reduce force. Normally the way we do it is always this one. We try to increase the time. Understand? Now what if terbalik? What if I want more force now? What should we do? Based on whatever I taught you if I want more impulsive force, the time is supposed to be lesser. Correct. What about top here? This one we increase it. Terbalik. Understood? There you go. Okay, now 4 marks. How do you get 4 marks? Try to imagine what your answer be like and quite easy, right? 4 marks means what? Helmet, safety pad. How do you get the 4 marks? You distribute your marks evenly Here got 2 marks, here got another 2 marks. Do you understand what I mean? All good, Always try to imagine how your answer be like before your answers. Okay, and then this thing works actually. You know why I teach you this or not? I'm not just trying to teach you how to answer this. I'm trying to teach you how to answer every impulsive force questions, right? If you want lesser impulsive force, doesn't matter. Is it like a helmet? Is it safety pad? Now, even let's say we talk about car. You know, car, we got all the safety features, everything. Same thing You don't want injured. You don't want die when you having car accidents. Reduce impulsive force. How we do it? We find a way to increase the time. Now, let's say impulsive force are very famous of coming out essay, because why? They can ask a lot of things about essay. Sports equipment, and then they got all kind of sports they ask you, right? But the logic same one. Whether you play skateboard, you play hockey, you play rugby, you play ice hockey, you play whatever If you don't want to injure, do the same thing. Have lesser impulsive force. Now, then at the same time, when we play sports, you got the bat, baseball bat, golf club, whatever. You hit the thing, you want more impulsive force, right? Then every logic terbalik. That's why you notice or not, all your tools, all your equipment that you use to hit something, they are usually hard material. Why? Harder material, shorter time, more impulsive force. You want lesser injuries, you don't want to get injured, more time, less impulsive force. The ballet logic. Understand? But for helmet and safety pad, you can talk about 2 things. 4 marks. Come on. You need more than that, okay? So first thing first, you tell the helmet first. Okay, the outer layer of the helmet made of. Okay, regarding this, I notice people also got this problem. When we say material, actually, must you tell what kind of material? The question is, can you memorize every one of them? Do you know what's the outer layer of the helmet made of? Your helmet made of what outside? Plastic. Okay, correct, but must I use plastic? Can I use other material? Can I use carbon fiber? Can I use glass fiber? Can I use those kind of composite fiber? You see or not, some of this you don't even hear whatever the name I give you. You've never heard before, right? So they cannot expect you to know every single material, right? So one thing, whenever they ask you what material should we do, always describe the characteristics. The outside layer should be made of strong material. That's it. I don't care. As long as the material is strong, can use. Must I do plastic? Must I do carbon fiber? Must I do whatever fiber? Doesn't matter one, as long as they are strong. And why do you want it to be strong? Okay, so that the helmet does not break upon impact. Okay, does not break upon the impact. So you want to make sure they don't break and protect the head of the girl. Not done yet, of course. You only talk about outer layer, right? Then what happened? Now, inner layer you can mention together with the safety pad because anyhow they are same thing, right? The inner layer of the helmet and safety pad are made of what kind of material? No lah, must I do sponge or not? I can do foam, whatever thing, but what do they have in common? Material that is softer. And why do you want softer material? So that the time of impact increases, and more time means what? Collision time, impact time, and impulsive force acting on the girl will reduce. Okay, acting on the girl will reduce when she falls on the ground. There you go. See? 4 marks. How do you get 4 marks? You see or not? You talk about the outer layer made of strong material so that the helmet won't break. 1 mark here. Explain yourself. 1 mark. Inner layer, softer. Why? Because the time increases. Impulsive force lesser. 1 more mark. See? So that's how the marks come from. So make sure one thing. Look at the marks every time. You need to make sure you worth the marks. You understand? Okay? Alright, any questions you can ask? If not, I need to move on. Let me know when you're done. You send me a helmet. Because 4 marks, man. If you just say soft, I got enough. If you just say soft, I got enough the marks. You understand what I mean? So that's why we talk about 2 things. There you go. Okay. Let me know when you're done. I need to move on. Okay. Impulsive force is the force acting or produced during impact, during collision. Next, other sports we have. Diagram 2.15 shows a sprinter doing 100-meter run. Okay. Now, when we say essay, right, it's a long questions. That one is 10 marks one. This one is like a mini essay, short one. But I want you to get used to doing questions like that. So over here, they say you need to suggest modification so that the man can run faster, the athlete can run faster and achieve a maximum acceleration. Okay, let's see. First thing first, the type of attire. What do you think the guy should wear? Now, attire means whatever he should wear. No, again, must I mention specifically what material? No, describe the special thing about it. Describe the characteristics, the shirts, the clothing, how. You think about all the, have you watched those, do you watch those Olympic games, whatever? People who run 100 meters. You should only wear underwear, not good that one a bit haram Cannot but normally what happened to their clothes? They wear like tight clothes, right? Actually, if you don't wear any clothes and run, it's slower one. You know why or not? Because your skin got hair. You got all your bulu. Yeah, that thing is gonna make you go slower one. That's why. Do you notice one thing? They usually shave, clean themselves. And now you think about all the Olympic games you watch. You notice all the guy botak on, or they have really short hair. Because the hair traps air, correct? They give you more air frictions. You go slower. But then you're supposed to wear clothes. Cannot. You say, can I just wear underwear? No lah. Okay. So the clothing, the shirts you wear supposed to be. Now you need to mention 2 things. Because okay, you know what? Some of you mentioned A, didn't mention B. Some of you mentioned B, didn't mention A. Yes, tight must be tight. Some more. One more thing beside tight. Jeans also tight what? Why you never see people wearing jeans and run? The clothes supposed to be tight and light. Correct. This one must mention both. Okay. The attire. Okay. Attire should be tight and light. Oh, yes. Regarding this, I need to mention every time when we answer questions, right, you need to understand you are doing physics, not English. All right. The grammar is not important one. You don't need all the beautiful words, all the flowery words. No need. Short sentence, straightforward. Okay. The attire should be tight and light. Because your teacher want to see this only, all right? She don't care what you want to. You don't need to write beautiful words, whatever, or the athlete supposed to wear. No need. Just put short sentence, okay? Explain yourself. Why do you do tight and light? I say already, why the clothes must be tight on? So that, okay, this is to reduce air friction. Yes, air resistant can, air friction can. Flexible, not, you didn't answer the question. Flexible, yes, but most importantly must be tight and light. Okay, now, not done yet, If you just say reduce air frictions, you didn't get full marks because why? To reduce air friction, that one is the function for having tight shirts. What about the light material? Why do you want it to be lighter? Can run faster. How do you put it in a physics way? Okay, to reduce air frictions and achieve a greater accelerations. Okay, lighter, go faster. How come? Now, I ask you a very simple questions. You see, do you remember formula for force? F equals what? No, I want the most basic one. F equals ma, right? What does it mean when we say the shirt is lighter? It means the mass drop, right? What happened to your A? Smaller mass means your acceleration is more. You understand? There you go. Next one, type of shoes. What kind of shoes do we wear? Increased velocity can, higher velocity can, but then when we say acceleration is more straightforward. Okay. Type of shoes, what shoes do we wear? Have you seen people running the 100-meter shoes? They're different. Sport shoe, not just sport shoes. The shoes for running are different. Underneath the shoes, right, you got all the studs, sharp one. It's like a nail. We call that as a spike shoes. Yes. Why do you wear spike shoes? Why people wear spike shoes? Because, right, the spike part, it's like a claw. Okay? Now, have you seen people wearing like slipper to run? Slipper? No, right? You know why people don't wear slipper to run? Because, why is it called slipper, by the way? Because it's slippery. But if you do spike shoes, what happens? It's like a claw, right? They when you step on it, they go down to the ground, right? They grip onto the ground. When you do like that, you see, you won't slip off one. But then you see slipper, see the difference? There you go. So shoes, the athlete supposed to wear should wear spike shoes. Why spike shoes? Reason of wearing spike shoes? Yes, to have better grip to the ground. Okay, and then they can run faster. Now, you know what means by the word grip? Grip means the good frictions. Yes, friction, some people say, hey, friction isn't it bad? Well, depends. Friction slow you down, but then you can't totally got no frictions one. Because when you got no frictions, you will slip off. So you need the good frictions. We call it grip. Okay, grip means the friction that makes you move faster. Make sure you don't fall down. That's the point. Next one, additional equipment. Now this one a lot of people actually don't know, but exam always come on. What do you need? You say runner, why got equipment one, right or not? Well, simple. Have you seen 100-meter sprinting before? They got this one thing that usually, okay, the proper one, not your school one. Do you realize one thing? For the proper one, when they start, right, they don't really stand there. They stand on something one. It's like a square, a rectangular thing. They steps on it. And then when they start, right, they kick, go forward. What's that thing? What's that thing called? Yes, the thing is called starting block. So why I need to mention, because a lot of people actually don't know the name. So why, as I mentioned, it's better. So the additional equipment, right, should have starting block. Right, reason. What's that for? You know how they do it? How they use it, starting block. The moment they start, right, what they do? They kick the starting block, then their body will go forward one. So this one is to exert a greater forward force and achieve a higher accelerations. Starting the time, they kick one time to accelerate themselves. The logic quite similar to people go for swimming. Swimming, yes, because people swim, right? They will kick the wall and then they can go faster the other side. Because every time we apply force on something, right, you get a reaction force pushing the other side. So you kick the starting block backwards, your body get pushed forward. Then you get a forward force and more acceleration. Why? Again, F equals ma. Force increased, A also increased. Understood? So these are the theory part you must know. Okay? Any questions you would like to ask? Understood? So far, okay? Alright, next one. If the man reached the finishing line in 10.2 seconds, calculate acceleration. Okay, now we know. What you should do? Whenever they ask calculate acceleration, calculate displacement, calculate time, calculate velocity, calculate all these things. Yep, linear motion, SUVAT, S-U-V-A-T, substitute inside. What are we looking for? What are we looking for? You want to calculate A, right? What else? S. Displacement travel. What do you think? It's 100 meter sprinting. So, obviously, 100 meter, right? Initial velocity. What's the starting speed of the guy? 0, of course. Final? Final cannot be 0. Final, you don't know, right? And then time taken? 10.2 seconds. All right. What kind of formula do we use? We got no final velocity. Okay. Which one? No final. 1, 2, 3, 4. 1, 2, 3, 4. Number 2. Okay. So S equals ut plus 1 over 2 at squared. Substitute inside and then we get answers 100. U is 0, so I multiply time everything 0. 1 over 2. A means what you're looking for. Time taken 10.2. Don't forget the square, by the way. Answer please. What do we get for this? Calculate. I give you a bit of time. Try calculating yourself. Once you're done, you send me the answer. I want to check whether you are correct or not. 10.2 square is 104.04 divided by 2. Regarding decimal point, you ask your teacher. She want how many give for me. Okay. But my opinion, my suggestions, right? 3 decimal point is quite safe already one. Because normally this kind of questions, your calculator, they give you the endless decimal point, right? So my suggestion is 3 decimal point. 2, I think quite little already, to be honest. Okay. No lah, without you got no frictions, you can't even run, You can't pick up the speed one because when every time you push forward, when the shoe got no frictions, the shoe, you're gonna slip off, you're gonna fall down. You can't even stand properly. So that's why you must have friction one. Alright, I think most of you got me the correct answers, and this is what we get. 1.922. Okay? Got it? Everybody? Okay, if you're okay, then can I move on? Send me a link. Yeah. Now we go to another topic. See or not? You see, one questions we have like SUVAT. Then after that we got theory. These are more likely to look like your exam questions. You understand? So I want to get of this, understand this idea how the exam looks like. Okay, number 2, diagram 4.1. But again, guys, now there's one thing I cannot guarantee the question I give you here will come out in exam exactly same. But there's one thing for sure is that I can guarantee the question I give you here it will be definitely be better than you buy reference book. Because if you buy reference book, right, you only got one book, right? Here, I look, basically all these questions, I get it from different reference book. I modified them before. Some of the question is my own questions anyway. So it will be more effective for you to practice. So you trust me lah, you try to do this. Answer you can find in the websites, okay? And then if you don't have, you are saying you are new students or my friend intro me, right? Ask your friend to send you also. If you are my own students, I will send in Google Classroom. It will definitely help for me. And then that's why I also behind I prepare a extra set. That one is for extra thing, because a lot of people during first exam, especially, a lot of people right got this problem. Like you got no idea how the exam will look like. Never done before. My first time in Form 4, right? So try to practice more. Okay. All right. Diagram 4.1 shows a space vehicle moving at 0.5 meter per second, about to dock a space probe moving in opposite directions. The mass of the vehicles and the probe is 2,500 kg and 1,500 kg respectively. After docking procedure, the space vehicle and the space probe move together 0.2 in the original directions of the space vehicles in diagram 4.2. Now, when you read this, you realize the question is very confusing. They do this every single time. So here we got two person basically. You got a space vehicle, okay? And then you got space probe. You can imagine this way lah. It's like two different parts trying to connect together. It's like robot combined together. Now I teach you a trick. Because a lot of people, right, you know what's the problem or not? You messed up. Because you see, you got all the number here, right? Then you say like, hey, how would I know actually which one is which? I'll tell you what, one thing very simple one. You try to highlight them with two different color. Just read through the first time. The first time you read through, right? You assign color for them. For example, let's say the space vehicle, I use blue color, and then the space probe I do purple color, right? So space vehicle, right? You see, moving at 0.5 meter per second, about to dock a space probe that is moving in opposite directions. The mass of the space vehicle is 2,500, and the space probe is 1,500. So next time, when you do this, you realize the good thing about this one. You don't need to read the question over and over again, and you don't make careless mistake like, oh, by right, the mass should be for the vehicle, then you put for the probe. You see, now I look at color enough, right? Blue color, okay? If I see blue color, I know we are doing space vehicle. If I see purple color, that's a space probe. Okay, after procedure docking, the space vehicle and the probe move together. Okay, now here we go. What does it mean by this 0.2? Whose velocity is this? Well, after, definitely, it's going to be final, right? But whose final velocity? You see, you know what's the keyword of this together? Together means what? Together means they move together means they got the same speed. Like, you know, when you're walking with your boyfriend or girlfriend, if we walk together, what happened to the speed? If you walk together, they're supposed to be same, right? Somebody say, oh, depends on if I argue with her, then she walk in front or she walk faster one. I say normally if we walk together, must be the same directions, same speed, same velocity, right? I got no girlfriend. Oh, sorry. Don't care okay? You get what I mean So that's the point. Okay. So over here, how we do this? Okay, first thing first, you know what is it about? What kind of questions we're dealing with here? Say two objects combine and then move together, right? Now this one will be under your momentum. And somebody asks you what is the collision occurs? Now speaking of this, momentum. Number one, actually momentum, right? If we just calculate momentum, right? The formula is actually mass multiply velocity. Okay? But then, right, of course, you know, exam not going to ask this only, too simple, right? So what happened here? You got all this formula here. Now, do you realize your collisions got three types? Elastic, inelastic explosions. Three things, right? Then you see all this formula. I tell you what, only the first one is important. Yes, because this formula come from here. But I tell you among three, right, you know which one come out the most? Elastic, inelastic explosions among three types of collisions. the last one, because only explosions has theory. Yes, only explosion, right? They got theory, they ask you explain this and that. Elastic and inelastic got no applications on. I'm not saying explosions will come out. Normally, exam they can do like, half elastic, half collision, explosion, or half inelastic. But if they ask you explain, right, definitely explosions. You get what I mean, right? Okay, good. Now one more thing, back to this. So we got elastic, we got inelastic, and then you got explosions, right? Okay. How to differentiate them? People always ask like, hey, they are so similar. How do we differentiate them? Right or not? Okay. Can they connect together? They can ask separately, no problem. Like the top part, they ask you calculate elastic. Then they give you another situations, inelastic perhaps. That's the thing. Okay. First thing first, you know how to differentiate elastic and inelastic? You look at after collisions. Okay. Elastic, right? After you collide, you see this V1, V2 means what? They move separately. One. They separate. That's elastic. Now, inelastic, right? After collide, you're gonna see words like they tell you they combine together, they move together, they embedded together, together. Because inelastic, right? Your final will be the same. Both person. That's why you know why we can factorize the V out, because they are same. If you multiply this back inside, you realize, right? They actually look exactly same as whatever on top. That's the thing. Now, explosions. How do we differentiate elastic and explosion? This one also, people confuse one. They say, hey, elastic explosion, right? The problem is what? They both separate. So I can't tell which one is which. Now, simple. Explosions, right? You look at this. Your initial explosion, right? Beginning, nobody move. Now, one person moving, one person not moving. That one not explosions are. Explosion must be both person not moving. Then explosions. Get it? Elastic, right? After initially moving, after collide, separate. Inelastic, initially moving, after combine, move together. Elastic, explosions, what's the difference? The beginning. Starting zero, explosions. Starting not zero, elastic. After that, both of them same, they separate that way. Understand? And all these formula actually come from where? Where do you think this formula come from? They come from this simple theory here. We got the conservation of momentum. Recall this thing? Okay, of course, definition, you want to memorize or not, your choice. But you know what means by the word conservation? Conserve means remain. Conserve means maintain. So most importantly, the key point, what's this conservation of momentum? Total momentum remain constant. Same. What means by constant? They don't change one. As in, before and after, they will stay the same. Okay? Like this over here. Before, you know why the formula M1U1, M2U2 equals M1V1, M2V2? Do you realize the only difference is U and V? U means initial velocity, V is final velocity. So whatever we have here, this is the momentum before. Okay, whatever we have here, this is the momentum after. You get it? Before, after must be equal. Momentum before, momentum after. But of course, you say, hey, if they are the same, right, then why are we calculating? You need to understand, there's two guys, So when I say momentum before, it's like total. Everybody sum together. Now, if you look at one person alone, they will change one. For example, that's what here could be like 3 plus 7 equals to 6 plus 4. You notice if you sum them up, they are both equals 10, right? But if you look at one person alone, the number can change. That's why I can calculate. But the logic simple. Momentum before, after, same, equal. Get it? So over here, regarding this momentum questions, right? You have to deal with elastic, inelastic, explosions. Now we go back to the questions here. What kind of collisions do we have here? What do you think? What kind of formulas? What kind of collisions should we do? Should you do elastic, inelastic, or explosions? No? You look at the questions, they give you a hint already, right? Space, vehicle, and probe move together. Very obvious one, actually. The moment they tell you, beginning, nothing move. That's explosions. The moment they tell you, after they collide, they combined, they move together. Then we got answer already, right? Okay, first one first. What's the answer for this? What type of collision occurs? Simple. That's what? Inelastic collisions. Yes, inelastic collisions. based on information provided, calculate total momentum. Okay, how do we calculate total momentum? Here's your keyword. What means by total? What's the meaning of total? How do you calculate normally? Like total. Total. Total means everything. Plus everything together. Yep. Okay. But do you need to calculate everything? Like everything? No lah. Now, here total means here before is total. After also total. You calculate one enough already. You cannot say then shouldn't we just we shouldn't be like add all of them together. No. Before is before, after right? So over here you can see what we have here, this is before. Okay? Then after that, this one after. Before they will combine, after they combine. Now which one you can calculate either one. You know why or not? Because before and after they are equal anyway. Just find one side enough. So which one do you think you will be able to find answers? Should you calculate before or should you calculate after? So over here, well, the question did tell you, right? The mass for the vehicle, it's 2,500. This one, 2,500 kg. This one, the probe is 1,500. But we have a problem, right? Do you know how much is this? Means you can't, right? Too bad long. But what about this? Can I find after? After same one, the mass is also 2,500. Okay. And then the probe is 1,500. Right. Do you have information for everybody? Do you have the velocity for the vehicle? Do you have the velocity for this? Why? Because they both same speed. Understood? There you go. So this one, right? When they ask for total, they didn't say before, after, right? Up to you one. You can calculate any one of them. But in these questions, you only got one choice lah, because the before, right? Not enough informations. So I take M1 plus M2. Now, you know why I factorize this out, right? Because they share the same speed. They share the same speed. Okay? System means this thing, it's a very general term to say that thing called systems, right? Mass is 2,500 and then 1,500. Final velocity is how much? 0.2. Total momentum can be after, before. Depends on which one got give information. You can calculate. Now, if they did tell you what is the momentum, what's the velocity for this, you can calculate also. They will be same anyway, equal. They won't change one. Okay? Now, answer please. What do we get for this? 2,500 plus 1,500 multiplied by 0.2. What do we get? 800, I suppose. Not done yet, of course. What do you need? You need. Form yourself. I say very time already. Whenever you do, there's so many terms. You can't memorize one. Just form yourself. And quite easy. Look at the formulas. What did you do? You took kg multiplied by, what's the unit for velocity? ms -1. So, multiply means what? Glue them together. There you go. Okay. Next one, speed of the space probe. Okay, the probe means the purple color guy. They want the speed of space probe before. What are we looking for? Speed of space probe before. Here's your keyword. What do you call this? Speed before. That's u, right? Initial velocity. Now, I need to look for the probe, right? You can decide the number yourself on initial velocity. Well, I mean, not to say number. I'm saying that here we got 2%, right? And then if you look at formulas, now you know why you got the M1, U1, M2, U2 thing, the number 1 and 2. Yeah? Because you got 2%. M1 means the first person, M2 means the second person. You understand what I mean, right? There you go. So that's why for this, up to you lah. But of course, what formula are we using? Definitely this one. What formula are we using? Inelastic. M1 U1 plus M2 U2 equals to M1 plus M2 and then V. What are we looking for? Now, let's say I decided to make this as number 1. That means, right, this is number 2. It's just code that you choose yourself. Doesn't matter one. If you want this one to be 1 also can, your choice. But if I set this 1 and 2, that means we are looking for U2. Okay, the rest we can substitute accordingly, right? What's M1? M1, mass of the vehicle, space vehicle, 2,500. What's the initial velocity? U1, initial velocity of the vehicle, 0.5. 0.2 is final, 0.5 initial. Plus M2, 1,005. U2 is what you're looking for. Okay, and one more thing actually, guys, do you realize this thing you calculated just now? Right. Well, if you're lazy, you can just put whatever number here. Not to say lazy, can use one, no problem one. But of course, say, I don't want, I want to be safe. I calculate again. Then by all means, up to you. Can just write everything again and again and again. No? Then the rest again now mathematics. Substitute and we get answers. 2,500 multiplied by 0.5. 2,500 multiplied by 0.5. This one is 1250. Okay. Plus 1,005 U2 equals 800. So I bring this over, become minus 1,005 U2 equals to 800 minus 1250. And what do we get for U2? $800 minus 1250. You get negative 450 divided by 1,005. Guys, what do we get? Okay, first of all, did you get a negative answer? Of course you should, because in physics, right, what does it mean when we get negative answers? In physics, what does it mean when we get negative answers? Physics, negative does not mean very small. Negative means opposite directions, correct? Negative means opposite. Negative means opposite. And look at the questions. Do you know why you should get negative? Because you see or not, they tell you space vehicle 0.5 meter per second. Space probe moving in opposite directions. Now, this is something I should remind you. In this chapter 2, there are 2 parts that you make mistake every time. Now, listen to this very carefully. There's 2 parts, 2 topic every time. Common mistake one. What is it? Number 1, momentum. Okay, because all this collision thing, you see, usually when we collide, let's say elastic, after collide, you separate way, right? You need to make sure you put the correct directions. Yes, if they tell you, oh, my velocity is 0.5, and then this one 0.3, if you see opposite directions, right, one of them has to be negative. Up to you, doesn't matter. Okay, I won't tell you to the left is negative, because negative is opposite. Can be to the left, can be to the right. Can, either one. So one thing you follow, if you got 2 directions, okay, positive, negative, positive, negative, right? Now, second part that people always confuse, again, the second thing is about impulsive force. Now, sometimes impulsive force, right, when we collide, can rebound one, they can go to opposite directions one. That one also another problem. Every time impulsive force also got same problem one, because this V and U, if they are opposite directions, make sure you put positive and negative as well. Get it? 2 things that people always forgot. Gravitational acceleration, that one also, you follow directions. If you got 2 directions, one positive, one you put negative. All good? So the negative here indicates that it's opposite directions. That's why you know you are correct. You should get negative. Okay, can I move on to next one? State and explain the principle involved. Well, what principle? What principle that tells you this? Okay, you know what, guys, look here. Pay attention. You cannot tell me inelastic. Okay. Principle, right, it's about this. Okay, where do you think the formula come from? How come we say M1U1 plus M2U2 equal to M1V1, M1, M2V? That's the principle. Okay, if they every time they ask principle, right, you cannot say inelastic, elastic. Now, that one is the type of collision. What happened? Elastic collision. What happened? Inelastic collisions, right? But what principle is involved? How do you know that your M1U1, M2U2 will equal to M1V1, M2V2? That one is under principle of conservation. Why they are equal? Because the total momentum, you see, principle. Okay, so this one, now why do I do this? Because every time people lose part one, principle of conservation of momentum. When they ask for principle, don't put, when they ask for principle, right, don't put elastic, inelastic, no marks one. Okay, next one. Explain. I mean, actually, they ask you state and explain is based asking for definitions. Yes, so you need to write the definitions for momentum. My bad. The definition for this principle. Now, definitions, you want to memorize or not, your choice. Not going to force you because, to be honest, definition, I tell you what, sure come out one. Okay. They will usually take about 5% normally. They will normally take about 5% of your questions. If you convert back, there are about 6 questions, 7 questions. So some people always got this misunderstanding. They will give me this mindset telling me, oh, my exam, a lot of definitions. But you know, definition is only 1 mark. So they ask you like even 5 questions, 6 questions. That's like 6 marks there. The theory question that we explain, all these things here, 1 question alone is 4 already. You understand what I mean, right? So definition, you want to memorize or not? Your choice, your choice. But I tell you answer is what? Definition for principle of conservation of momentum. Okay, they tell you what this principle, the total momentum of the systems is always constant can, conserve can, okay, provided what? There is no external force acting on the systems. System is a general word to describe whatever you're having. Could be a rocket, could be whatever thing. When we say system, it's like the whole thing called systems. Okay, total momentum of the systems is always constant, provided there's no external force acting on them. Next one. Okay, acting. Now the one English word not important. You can change yourself a bit. Describe propulsions of a rocket in terms of momentum. Okay, this one I must explain, and I teach you a trick . A lot of times, right, when you understand, your question become easy. You don't have to memorize so much. Why do I say so? You see, just now, you know, when I explain this, you know why I go detail about the you know why am I going very detailed about this? Because I don't want you to just know how to answer skateboard questions. In the future, they ask any sports, you want to reduce injuries, you do the same thing. Like high jump, why people put mattress? Same what, right? Now this thing here, remember I said, right, the momentum question they ask you to explain must be what kind of conditions. And now think about rocket. What do you think? Rocket should be what kind of collisions? Elastic, inelastic, or explosions? Rocket. Have you seen rocket launching before? Propulsion means launching, like rocket all the way up. So what do you think? Rocket. Do you see we use something to collide it? Do you see we use something to hit the rocket and then it go to space one? No, right? The launching is what? Starting. The rocket stay there one. Have you seen rocket launching before? You know, if you let's say NASA, when they launch a rocket, they will do live on YouTube one. Now so you see, at first the rocket stay there, right? And then they start the rocket, they light up the rocket, start, then what happens next? The moment they ignite, you get a lot of fire, a lot of smoke coming out, all the way up, right? So initially, nobody move, right? The rocket never move. Or the fire, the smoke never come out. That one means no velocity. You understand? Now, what is the thing that shared same theory beside rocket? What else also? Explosions one. Okay, you know what's a jet engine? Do you know what's a jet engine? Airplane. The wings there, you have like a row, like a barrel, and then got fan, like it's like a huge fan. That one is not a fan, that one is a vacuum. They suck air in. Airplane concept, rocket concept, all same one. So now I'm telling you, next time they ask you any questions regarding explosions one, answer like that. How we do it? Number one, can you tell me the formula? Can you tell me the formulas for explosions? Formula. Jumping, consider yes, depends on where you jump, how you jump. That one depends. If you jump from a skateboard, then yes. Because you go forward, skateboard go backwards, right? Okay, so explosion formula is what? 0 equals to m1 v1 plus m2 v2. Notice I like to use formulas as approach every time. Because like that easy to understand, right? Then you don't need to memorize so many things. And again, I say many times already, theory, you go and memorize, you cannot finish one. There are so many of them, you understand or not? Okay, can you bring this over? M2 V2, if I bring it over, what do we get? You bring to the other side, I get negative. Agree? I'll be getting, what do we get? Negative. You'll be having negative M2 V2 equals to M1 V1, right? Okay, that's your key essential here. Why do I say so? Number one, what do you know? What do you understand about this? First thing first, what's this? What means by the sign equal? It means that the value here and here would be the same. But then, do you see this? What's the meaning of the word negative? Negative means equal, yes? But sorry, negative means opposite, right? So when you put them together, it's what? It means you get equal but opposite directions. Yes, the number be same. And next, now, we got 2%, yes? You got M1 and then M2. So for rocket, who's this M1, M2? Like for example, this one here, I can say this is number 1, this is number 2, right? Now what about rocket? Rocket, who's the M1, M2? Never mind, I give you a diagram of rocket. You tell me . So let's say this rocket here. Okay, this rocket, all the way. What do we have? Of course, rocket is one of them, right? But then, what else? What else? Rocket is one person, then you got all the smoke coming down, right? Okay, first thing first, don't say this fire. No much fun. Okay, because it's more than just fire. Right? Think about it. When they launch, right, you just get fire. You get a lot of things, right? You got fire, smoke, everything, right? Now, I give you a word, you learn this, okay? Whatever come out from rocket, after combustion, rocket, jet engine, all same one. Okay, they are called exhaust gas. Okay, whatever come out after the combustions, they are called exhaust gas. You following? Can exhaust gas, So over here, what is the 2% we have? Now, let's say rocket, I put it number 2. And then the exhaust gas, I put it number 1. So what is based on the formula, what do we know about the relationship? The momentum of the exhaust will equal to the momentum of the rocket. But then, the exhaust will go down, the rocket goes up. Because why? They will move with equal but opposite momentum. Understood? Okay, now how do we answer? Again, this kind of theory questions is always 4 marks one. Okay, so what do you think? How should you answer the questions right now? Okay, first thing first. Wait, let me do a bit of cheating. Okay, I need to ask you one thing first. How do you answer this? Well, first thing is, imagine yourself having this. Okay, imagine yourself having the rocket. What's the first thing we do? If you want the rocket to start to go up, all the way up, step 1, what do we do? Like you want the airplane to move forward, you need to start engine, right? You need to launch it, right? Okay, for rocket, how do you launch rocket? You need to have combustions, right? So you need to mix the fuel and air. After combustions, what happens? Boom, you start having all the fire, all the exhaust gas coming out, right? Then next thing, if the fire start going down, what happened to your rocket? If the fire start going down, what happened to the rocket? They go where? What directions? They go up, right? Okay, now Let me show you the answer. Don't copy anything. Look here will do. Okay. Now, this one. Look here. Look here. I give you time. Relax. Okay, first thing first, what do? Fuel and air mix together. Combustion starts in the combustion chamber, causing explosions. First mark. Okay, exhaust gas, they will exit the nozzle at high velocity. Velocity higher means what? Your momentum also higher. But then you must mention about this downward momentum. According to principle of conservation momentum, this one easy. Put in your theory only, your definitions. Total momentum always same. Therefore, the rocket will move upward with an equal but opposite momentum. Get it? Okay, so how do we do this thing easier? Okay, first thing first, I need to clarify one thing. This thing. The word explosion here might not be what you think it is. When we say explosions, right, not like kaboom explosions. This one, you are trying to tell them that the rocket is having explosion as the type of collisions. So let's say lah, if the collision type is inelastic, then you say inelastic collision occurs. But this one here, rocket, is explosion. Then we say explosion occurs, causing explosions. So this one, you are trying to say that you have explosions, as in this explosion. Get it? And then must mention directions, because this one will change one. No lah. Elastic, inelastic, got no theory explanation. But I want you to understand the word explosion here is not kaboom explosion, it's the collision type explosions. Okay? And then produce a large downward momentum. Must mention, because why? If it's for airplane, can I say downward? Airplane will go backwards one, then put in your theory. After that, rocket move upward, opposite directions. This one also must mention equal but opposite. Okay, guys, stop. Don't copy. Look here. Now, when you understand, life becomes simple. Why? Look at this. You know what's a jet engine, right? Airplane. Air comes in, combustions, exhaust gas. Agree? Then see, how do we answer it? Number one, air mixed with fuel. Combustion starts, explosion occurs. Okay, now? Do you realize we are saying the same thing? Exhaust gas, exit the exhaust nozzle. Oh, by the way, nozzle means the exit. Nozzle is exit. Yes, the exit. High speed means what? High momentum. And then remember, mention the directions backward now. Because you want airplane, we don't straight away go up one. We push the airplane forward first. That's why you want the airplane to go forward. You want the airplane to move forward, your exhaust go backwards. According to, see, there we go, throw in your principle, blah, blah, blah. And then finally, jet engine produce an equal but opposite forward momentum. See or not? You mention backward exhaust gas, then your jet engine forward. Rocket, simple, right? Same thing. Fuel mixed with air. Combustion starts, explosion occurs, right? Exhaust gas will start to move downward with high velocity, and that's why you got high momentum. According to principle, blah, 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 same thing. Rocket will move upward with an equal but opposite momentum. Understood? Then you read, the more you read, you realize, actually, they are the same. The format more or less same one. So that's why I tell you, I'm not saying that you don't need to study, but you're seeing the idea now. When you understand it, the format, your life becomes simple, You are literally changing one thing only, Yeah, you are just changing the directions. For rocket, it's up and down. For jet engine, it's forward and backward. Understand? We good? This one? Okay. Can ignore exit nozzle? No lah. Must mention one. The exhaust, you must tell where does it go, Okay, guys, now you can copy. That's why now you see or not, blindly memorizing theory, you're not gonna last, because the more you study, the more you have to start memorize, right? But when you understand things, you know what are you doing. You can copy, no problem, but you need to know what are you copying. Okay? All right, guys, copy this down. If you're done, right, then you send me a rocket like this. You. I mean, you need to adapt your questions. Like if it's, let's say they ask you gun, then they become bullet. Ah, that's why I say don't memorize. You adapt your questions. Why do we say exhaust here? Because this one involves burning, combustions, then we got exhaust gas one. But then let's say they ask you to explain why the gun recoil backwards. Gun where got exhaust gas, the gun will become what? Bullet go forward and then the gun recoil backwards. Same thing one. When the gun is fired, explosion occurs, right? Bullet exit the gun at high velocity, producing high momentum. According to principle, same thing. And then the gun will recoil backwards with an equal but opposite momentum. You see, I can just roughly tell the answer straight away, right? Because the format same one. You're just changing the character, changing the name only. What? Okay. Let me know when you're done. I need you to move on together. And yes, rocket. Where's my rocket? All right. Can we next? Okay. Now essay. Okay. Regarding essay, I think you heard of teacher mentioned before, right? The teacher mentioned before. But do you know how many type of essay you have? We got different types of questions of essay. Okay. Essay memang 10 marks one. But then we got two types of essay. I tell you one by one. Number one, these kind of essay, all right, this type, I call them as the design essay. Okay, design means what? Normally, if we talk about full format, like for real SPM paper, this kind of design essay, they will show up in your section C. So if you're having full paper this time, if your school, your teacher having full format paper, you will expect this kind of essay come out in your section C. Okay, the design one. Basically, they will give you a scenario. They say, oh, you know what? I need help with designing this rocket. I want to go faster. That's section C, design essay. Now, you also got section B. This one I go to later. You look here first. All right. Now, this one, it will be the section B punya essay. Why do I say so? Because this one, right, you will see they give you a table. This one, right, I call it as the decide essay. So very simple. You got different D and D. Design, decide, design, decide. Draw out as in what? Draw this table. No, this table they give one. So the differentiate them, simple. If they give table, let you choose. You are making decision, right? That one is called decide. Section B, they come out. Now, if this time your exam got one essay only, okay, your teacher say only one essay, higher chance is decide will come out. Higher chance. Normally midterm, because a lot of school like to do combined paper. Then they only put one essay inside. Then normally this one come out. Normally, I'm saying normally, okay? But both you need to learn one, because in the future, you need to learn. I mentioned both to you. The format, very important. Okay? So can tell difference, right? This one is design. Do you see any table? They let you choose. No, right? Everything you write yourself on. Now this one is decide. You got table there. You decide yourself which one is the best. Got it? Now, of course, people say, hey, then this one isn't it harder, right? This one isn't it harder? Yes, it is. That's why people don't like this stuff. But depends on school. If you got if your teacher tell you got two essay, then confirm. One is design, one is decide. Okay? If your teacher got one essay only, then normally they come out design first. But both learn. Now, how do we do it this way? Number one. Okay? Answer your questions in table. No, again, I don't need fancy words. I don't need beautiful words. Just straightforward, short sentence. That's it. But the table, this table you draw yourself on, they never tell you. They're not going to draw for you. Okay, you get a full scale paper, end of story. Okay, what do you put for title here? One side here you put design. No, that's why I call it as a design essay, lah. Right? You can say modification design, up to you, lah. And then the other side here we put reason. Okay. Now 10 marks. How do you get the 10 marks? 10 marks simple, lah, right? How many points we have here? Okay, this question, you see, they be kind to you, right? Okay, they be kind to you, right? They tell everything, but sometimes your teacher, they don't tell. They just give you like extra, like they put a word others there. So you need to know yourself that that's why essay is like that one. The more you do, the better you are at it. If you don't want to do, also can read the questions, look at the answer straight away. When you do this more, you will, even they come out like they only give you 4, then you can add on 1 more yourself. You understand? No drawing, no, they don't. Essay we don't do drawing. Don't. Okay. Now here, you are required to give suggestions. You can write, this one title not important. I say already lah. You want to put suggestions, design, whatever, up to you lah. You want to modify this water rocket. Have you seen this before? Okay. Have you seen this before? Can travel maximum horizontal distance. Your school got do this or not? Science project. I mean, some school got this kind of competition kind of thing, right? Okay, but then you need to read, you need to read, maximum what? Horizontal or vertical distance? Vertical means they want to straight all the way up one. Whoever can fly highest wins. Now, this one, they want maximum horizontal distance. Means, you know how they launch it? If you want maximum horizontal distance? No, they don't do this up one. They launch it at an angle. Okay, one by one, Alright, 1, 2, 3, 4, 5. Okay, first thing first, material used. Okay, I tell you one thing lah. Every time people got this problem one. When we say material, actually you don't have to mention specifically, oh, I need to use plastic, I need to use whatever. I say already ma. There are so many material. How do you remember all of them, right? There is always a better material. So what do we do every time? We always describe the characteristics. Yes. Now, you want this thing to fly further. You want this thing to fly faster. What do you think? The material, how? What is the characteristics you must have? Strong can, but that's not the main priority though. Can say strong now, but what is the better answer rather than strong? Yes, you want to go faster. It has to be lighter, correct. Smaller mass, right? Okay, I teach you one more word. Don't say lighter. Lighter very low. You want science answer, right? You learn this word called density. In next time, whatever chapter works one. Density means, density very simple one. Density means the mass. Denser, like when your density is higher, means heavier. When your density is lower, means lighter. Okay, why do I say so? Okay, density, right? You know what's the unit for density? Unit. Density punya unit is kg m minus 3. How do you pronounce this? Kilogram per meter cube. Kilogram per meter cube. Means every meter cube, how many kg? Let's say 1000 kg per meter cube. Means 1 meter cube, the mass of it, it's 1000 kg. For example, water. Water density is 1000. Means if I got 1 meter cube of water, 1000 kg. Now, let's say for oil. The density for oil, right, it's only 800. Means same amount of 1 meter cube of oil, only 800 kg. That's why you know why people tell you oil is lighter than water. That's the reason. Okay? So learn this word lah, density. Next time we use it all the time. Okay? Material. First thing, the material of the rocket should be low density. You know why I say do this way or not? Because you say low density material of the rocket should be low density, right? Then next thing, how do you explain yourself? The reason? So that the rocket is lighter. You see that or not? The lighter is your reason. So if you put lighter here, you can't explain yourself here. You get it? So here's your point. Here's your reason. So every time we say low density and then we say lighter. High density means what? Heavier. Okay? Now not done yet, of course. So the rocket is lighter. Okay? And then some more. And able to travel faster, travel further distance, all can. Travel further distance. Travel faster also can. Okay? Travel able to travel faster, higher velocity, all this. Can your reasoning, right? No limit one. You just make sure your answer is logical, related. It can. Acceleration also can. You see, reasoning here, when we explain, your answer makes sense, your teacher give you marks already. But most importantly, here must be the correct answers. Next one, shape of the rocket. What kind of shape? Now there's a very specific name for this. You cannot say pointy. That one is like, form 1, form 2 say pointy one. Yes, pointy, but why they need it to be pointy? The shape got name one. That thing is called aerodynamic. Okay, now I write this down. The shape of the rocket should be aerodynamic. Okay, have you heard of this word before? Streamline. Okay, I tell you what, don't panic when you see this. Streamline and aerodynamic, same. Streamline and aerodynamic, same. It's exactly same shape one. So, theoretically, you write the rocket should be streamlined, correct. The rocket should be aerodynamic, correct. But normally your teacher, right, she will prefer it this way. Listen, if you want to reduce air frictions for air, then we do aerodynamic. Streamline is for water one. If you want to reduce water frictions, water resistance, we do streamline. Get it? Let's say submarine, ship. This one, right? We write the shape should be streamlined. Airplane, rocket, train, bullet train, car. Then we say aerodynamic. Your teacher will prefer it this way. So normally, if you are doing design questions, you write yourself, right? You'll be more alert about this. Okay? So the shape should be aerodynamic. Why? You know what's the function of this shape? Shape aerodynamic, what they do? They can, yes, to reduce air frictions acting on the rocket and move with higher velocity. Okay, one thing when we're explaining ourselves, right, I will suggest one thing is that try not to have the same answer. So up here we say able to travel further distance, and then here we say move with higher velocity. You try not to have the answer that is bulat say. Don't exactly say. Change your rephrase your sentence a bit. Your teacher don't mind about that. Okay, next one, the angle of launching. Remember I said, right, we're supposed to launch it with a certain angle. What is the angle of launching? Angle, like, degree how many degree? Now definitely your rocket is not gonna launch vertically already So now let's say the rocket like this rocket. Okay, rocket. This is the angle here. What is the angle? How many? Not specified value one. It's a specified value. 45, 30, 60. Choose. The angle should be 45, 30 degrees or 60 degrees. Answer is 45. You know what's the problem? Okay, let's just do 60 first. If it's 60 means your rocket is a little bit too up here, right? Then what happened? Most of your force is used to go up. Your rocket be like this. If you do 60 degree, your rocket will do. They can go very far. I mean, they can go very high, but they don't go far because most of your velocity is go already. That's what happened for 60. Now, then you say, then shouldn't we do 30 degree? Isn't it like all of them will go forward? Yes, it is. But we have another problem. If you do 30 degrees, right? Okay, this is the ground, right? They will shoot like this. They do not have enough time to go further. They already landed because gravity will drag you down. So the best is you're supposed to do 45 because why? 45 is just half, right? Half of them go up, half of them go balance, perfect ratio. Now again, if you do 60 degree, your rocket do like this one. Yeah, very tall but very short. This one 30 degree. Whoop, before they manage to go further, you landed already. Finally, 45 degree. See? So 45 is better compared to these two angles. Okay? Alright, so the angle of launching should be 45 degree. How do you explain this? You cannot tell, no need to go all crazy, all the mathematics lah. 45 degrees, more balance, right? And what's the good thing about this? What's the good thing about this? The rocket will be able to travel furthest. Oh, sorry. Make it shorter. So that the rocket have a maximum horizontal distance. They can go up and then go forward. Next one, volume of the water in the rocket. Have you seen this before? They put water inside and then they pump the air inside, pump, until one point, right? They burst. The air inside push the water out, and then they start going up. So the volume of the rocket, how many? Okay, of course you don't need to tell exactly how many ml lah. Like in terms of ratio, in terms of like fractions, how much should it be water and how much should it be air? Where can full, then how you pump air inside? So here's the question: how much? What's the ratio? Half water, half air. 75% means 3/4 of water. 1/4 of water. Now we are doing water. Water how many fractions? Now the best ratio is actually 1/3. The best ratio is actually 1/3. Some people say, hey, isn't it half? Because half water, half air, fair, right? Now, you need to understand one thing. What is the thing that is pushing the water? You need to have the water shooting out at high speed, right? The pressure of air need to be very big. And you also need a lot of air to push it. So when you put too many water inside, you do not have space for the air to go inside. But at the same time, why don't you just put air? Because mv momentum is mv right? You want to increase both of them to get your more momentum. So the water is to have more mass. But you cannot be too heavy until they can't even launch. So the perfect balance point, 1/3 we put water, 2/3 we put air. So we got more space for the air to push the water out with higher speed. Then you get more momentum. So the volume of water in the rocket, the volume of water in the rocket should be 1/3. 1/3. Why? This one is to make sure, okay, to reduce the mass of the rocket and it will take off easily. Cannot be too heavy. One half cannot lah, to be honest. 1/3 lah. Finally, additional structures. You need to add something on the rocket. Actually, the diagram got answer already. You look at the diagram. No. Yeah. That thing is not called wings. Ini bukan wings. What's this? The volume ratio need to remember one. To be honest lah, this one memang need to remember. That's why I do these questions. Because you need to go through very complicated calculations to get these answers. So the best way to remember them. That thing is called fin, not wings. How many fins do we need? The balance one should be 4. You want a more stable one, 4. 3, not to say cannot. 3 can, but then you need to measure angle properly. You need to make sure you divide the 3 fin, right, equally spaced. But then 4 is easier lah. 4 you can just put diagonal like that, sure, equally spaced already. But if you do 3 fins, okay, this is the rocket, right? You need to make sure they space out exactly 120 degree, 120 degree, 120 degrees. Very difficult one. So what's the best way to do is like just, like that, easy, right? One fin, one fin, one fin, one fin. You know what's the fin for? One more thing. You know what's all this fin for? Not to go faster. Not to go faster. The fin, right, is to make sure your rocket more stable one. No, not to stand. Rocket more stable. Now, let's say random let's say imagine this rocket without fin, right, your rocket will do like this. The moment you launch and then they start wobbling. They go and then they go random places. That's the problem. Okay, I can give you one simple example. Balloon. You can try yourself balloon. You blow balloon all the way, then you let go. You realize the balloon fly everywhere, right? They don't go straight on. That's the reason. When you have one thing without no fin whatsoever, your air will disturb the directions. They will start flying everywhere. So why do you put fin? Is because the fin, right, they cut through the air. And then if you put four, they cut through them, they become four small portions, and then they will straight forward. They will be more stable when flying. You're not going to swing, topple here and there. You get what I mean? There we go. Okay. All right. So the fin is for stability. The fin is for more stable, can fly more straight and everything. Not to go faster, actually. You can't say higher speed whatsoever. Okay. So we should install fins on the install equally spaced fins on the rocket. Okay, this one is to ensure the rocket, to increase the stability of the rocket during its flight time. Flying the time more stable, they don't wobble and everything. Can say stable and cut through air. Say stable, don't say cut through air. The moment you cut through air, that one is aerodynamic already. Okay? So that's the concept for your design essay. How many points we wrote? 5 points, right? Your EC, your Hurayan, your EC, your Hurayan, your EC, your Hurayan, your EC, your Hurayan, your EC, your Hurayan. How many marks here? Design punya essay, 5 points multiplied 2, you get 10 marks. Okay, Now, this one, you write down the answers. Let me know when you're done. I will also explain about the design. I got a bit more time. I need to finish everything. I want to make sure you can do both the essay type. Okay? Let me know when you're done. Oh, if you wish to have a replay for this, I will post it in my YouTube channel as well. You can watch them again. Maybe just now you slightly blur a bit one part. You want to watch back whatever thing that's recording for this. You can go to YouTube. You search my name. You're supposed to come out. Okay. This one. And inside, perhaps you find some other videos that helps you. Okay. Got Mandarin, got English version. Just go and find. Yep. Instagram also can find. Right. But then Instagram, I got other videos one. Yep. No lah. To be honest, this one is just that reason I do YouTube is because I'm too tired to answer the same question 1,000 times. So every time student ask me a question that, I feel like I answered before, I will just show them the video. Especially those topics that need more explanation. YouTube don't earn money one. Especially when you do all these educational channels. Not going to make a lot of money. If it depends on YouTube to earn money, then I probably die already. Are we done? Next. Okay. Can we look at the design questions? Since we are doing the momentum, might as well. Rocket also we do. And next thing, can we look at page number 15? 15. No. We're not doing this whole thing again because you should be able to answer this already. Principle, copy. And then the working principle, I told you the format. Okay, this one, section B. Now this one you need to choose first. First thing first, the design. How do we do it? Number one, the nozzle. Hey, this one typo, my bad. Nozzle is like this. Nozzle. Kerosene also typo though. Yeah. Kerosene, I think should be kerosene, not kerosene. Later you know lah. Okay. All right. First thing, the nozzle, should you have a big diameter or small diameter? Nozzle as in here, you see, air comes in from here, combustion, and then exhaust comes out. The nozzle means what the mouth, the exit for the exhaust gas. So the nozzle here should be big or small. Okay, first of all, do you want the exhaust gas come out high speed or low speed? Do you want the exhaust that come out here velocity high or low? High speed, because velocity higher, momentum higher ma. Velocity higher, momentum higher ma, right? Then your airplane go forward more, right? So here's the question, the nozzle should be big or small diameter? Bigger, smaller? Okay, let's do a very simple experiment, okay? Now you take a deep breath and then open your mouth as big as possible. Breathe out your air as fast as possible. Then, okay? Now we change. Take a deep breath. Close your mouth small and then blow air. Which one faster? Which one faster, the speed? You got asthma, hey, too bad for you, I also got asthma. For real, ne? You got this thing or not? That's an inhaler. That one must have one, if not sure that one. So yeah. Which one the air come out faster one? Those who laugh people, you all those the person who laugh at people having asthma. Need to go to hell one, you know. Small one, right? Small one, the air can go faster one compared to the right. So of course, smaller down nozzle. Okay, the velocity faster. The velocity faster. Size of propeller. You know what's the propeller, right? The fan in front. You know what does the propeller do? A lot of people don't know. Propeller is not blow air one, they suck air one. This thing, right? It cause the air to go inside, man. They draw the air inside. So do you want the propeller big or small? 3 marks lah. The fan, you want big or small? Of course, bigger, right? Bigger size means more airflow. Okay. Next one, the type of the fuel. Okay, that's the thing lah. You ask me, right? What's paraffin? What's liquid? This is something that's why I say, you know why I say you must read more, you must know more. You will learn things that is a bit off your syllabus, but it's considered general knowledge. Okay. Well, simple. Kerosene, kerosene and paraffin. Kerosene and paraffin, right? They are the fuel for airplane. Kerosene for paraffin also, we can use it for airplane. So since I give you answer already lah, kerosene. You know why we don't use petrol? Airplane nobody pump petroleum one. Because the petrol for the car, right, not good enough. Your combustion not good enough. They don't generate enough power for airplane to fly. So they will need you can see it this way lah. Kerosene is like a better version of fuel compared to petrol. So kerosene is better. You know this one for what? Liquid hydrogen. Liquid hydrogen. This one rocket. But no lah, to be honest lah, airplane most common one is kerosene lah. Paraffin also we seldom use already one. Rocket. You know why? Oxygen if you mix oxygen with hydrogen, what do you get? Oxygen and hydrogen combined together. Water your head. Hello, your chemistry teacher want to vomit blood already. Water is when you mix it with correct ratio. Air plus oxygen, bomb, they just explode, okay? Rocket, you need the explosion, right? Sudden boom, explode, go up, right? But then for airplane, do you want bomb? You need to fly for like 8 hours, 6 hours, 10 hours, right? You need the long-term fuel burning, right? So we do kerosene, okay? Kerosene you put inside car, your car go faster, but you need to understand one thing. If your car is a MyV, you put what inside also, it's a MyV. Okay, don't expect your car do something different. Okay, now size of the combustion chamber, 3 marks. The area that you burn the fuel, oxygen, what do you want? Of course, bigger. Why? Because after burning already, they become exhaust gas, right? So bigger means what? More exhaust. Oh? And finally, which one is the best? What answer do we choose? Of course, L. There we go. Now pay attention. The side essay different. Just now, notice what we do, right? We straight to the point. Isi, huraian, point, answer, 5, then 10 marks, right? Now this one here, how many points do we have? How many expect do we have? We only got 1, 2, 3, 4, right? Okay, so the way we answer for this a bit different. Okay, first thing first, the title, you can put choice, you can put expect, whatever you want. Title not important. Reason. Okay, and you look at this table, do you realize it's different? Do you realize the last column, I never separate them? Because number one, never jump to conclusion straight away. Means I don't want to see you telling me first sentence, L is the best. Your marks gone. 0. Yes. Now, this one is always last. You tell your conclusion last. Like, you know when you do the experiment, you think about it, when you do an experiment, do you put your conclusion last? I mean, sorry, do you put your conclusion at the beginning? My experiment will be like this. No, right? So this one, we don't care first. Leave it. What we do, we list down all the criteria. What, in your mind, what's the best jet engine? Okay, first thing first, you tell them, okay, the nozzle diameter should be smaller. Why do you want smaller diameter? Just now we said already, am I right? Smaller diameter means what? So that the exhaust gas will exit the nozzle with higher velocity. Higher velocity, producing higher momentum. Okay? That is what we say just now, right? Okay, next one. Size of the propeller. The size of propeller should be bigger. Should be bigger. Why bigger? Propeller for what? Propeller spell wrongly, man? No. Okay. Propeller bigger means what? The fan bigger. Able to draw more air into the jet engine. Okay, more air means more combustions. Alright, next one. The type of fuel. Now, this one you need to mention both because actually paraffin can use also right? So, absorb wrong. We don't use the word absorb. Okay, the fuel should use paraffin or kerosene. Because both is accepted, so you need to write both paraffin or kerosene. Why? Why do you use paraffin or kerosene? Why don't you use petroleum? Because this one, right? Okay, so that it has a higher level of combustions. Okay, produces more power. Most importantly, mention a higher level of combustions. Finally, the size of combustion chamber. The size of combustion chamber should be bigger. Why bigger? Because bigger means what? Produces more exhaust gas during combustions. Okay? Now, after you say all the points already, then only you conclusion. Because why? You see, actually for the side essay, right, a bit different one. You only got 4 points. So if you do everything correctly, point, explain, point, explain, point, explain, point, explain, you only get 8 marks. Am I right? Then where do you think the extra 2 marks come from? Simple. Final answer. Therefore, what's the best? Most suitable jet engine should be design L. Because now you copy everything again. Like literally what you said just now, the best. The nozzle should be, because the nozzle of sorry, my bad. Because jet engine L has smaller nozzle diameter, bigger propeller size, bigger combustion chamber, and uses kerosene as fuel. Like for you just copy again, they give you marks. So you choose correct, they give 1 mark. You copy everything again, they give 1 mark. So another 2 here, that's why sum together 10. Okay, so the format a bit different one. You must know how. Okay, you must know how. If not, your essay, even you know the answer, you don't get full marks because the format is important. So only for the side essay, you have to do conclusions. Okay, now guys, let me clarify this. You later you can copy that. Stop. Look here. Listen. Design, right? No need conclusion one. Design, you just straight away tell them what's the best, why you do this. That's it. I mean, this one is your design. Come on. What is your conclusion? Therefore, my design is the best. No, right? That one is because we are choosing. That's why we have to do conclusions. This one, right? You just write whatever design. So 5 times 2, 10 marks. Design essay. Now then design, done. And then decide one, right? You choose. After tell them all your criteria, and then conclusion. Which one the best? Because copy everything again. 2 marks. Understand? So that's the trick of doing it. Don't write paraffin is fine. I would suggest write to be honest, because paraffin can be accepted. Any questions about this? Can I get an airplane? Like this? So now, today we mainly focus on revising a few things. We talk about the linear motions formula. We talk about the impulsive force, how to explain, right? All the sports, next time you know how to prevent injuries, right? Then momentum, how do you explain the explosion format, right? After that essay, we did 2 essay anyway, which is very good progress. 2 essay, 2 different type, because you must know the format. Okay? Any questions you'd like to ask? Conclusion, no need, because the jet engine L uses kerosene. So you write kerosene. Because the design L is kerosene, so you write kerosene. Okay? Alright, if you have no questions, I hope you learned today. I hope you learned a lot of things today. That's it for today. If you have a question, you can stay for a while. If not, then that's it. All the best for your exam. I hope to see you again. Bye-bye. Wait.